Meetup. Nice to meet y'all. Thanks for the introduction, Chris. So I'm here to talk to you about ClojureScript and especially how it relates to React. This is the first time I'm giving this talk. It's brand new. So actually I should put something here so I can keep track of the time. I might have to run through some parts, or if I have time left in the end, I can give you a bit of a demo. So ClojureScript, for those who don't know, is a Lisp. So warning, there will be Lisp in this talk. So that looks a bit like this. This is the kind of stuff we'll be looking at. This is a React and ClojureScript app that you're looking at. The only thing that it does is that I can change these colors. Which one do you think looks best? Maybe this one's kind of nice. Yeah. Okay. We'll have a lot more to say about the stuff you're seeing here, but I thought kind of, to not bury the lead, to just straight up show you what we're talking about. So my name's Arne. I'm a Clojure/Ruby/JS dev, kind of in that order. Originally from Belgium, based in Berlin, last 4 or 5 years. And my main activity nowadays is running this site, Lambda Island, where I make video tutorials about Clojure and ClojureScript. It's subscription-based. There's some free stuff, there's some paid stuff. There's now 26 or 27 episodes, I think, about 5.5 hours of content. You can check that out. But so yeah, we're here to talk about ClojureScript. Who of you have heard of ClojureScript? Okay, that's most of the room. Who of you have used ClojureScript? That's a lot less. And who of you still uses or would use in the future ClojureScript? Okay.
Of course.
Actually, slightly more than the ones who have used it in the past. So that's good news, I guess. But so this kind of it corresponds roughly with this is from the JavaScript survey, user survey from last year. I know that the legend is very small, but basically from the left it's plain JavaScript, ES6, CoffeeScript, TypeScript, Elm, ClojureScript. And then the bright pink is use it but would not use it again. The light pink is used it and would like to use it again. The bright or dark blue is heard of it but I'm not interested. And the light blue is heard of it and I would like to learn it. And then the gray is never heard of it. So you kind of see, well, I mean, not surprising that JavaScript and ES6 have the biggest chunk of use it and would use it again. The people that have used ClojureScript, it's really not that many. Of those, a majority would use it again. And there is a big chunk that wants to learn it, but like less so than sort of the other two, TypeScript and Elm, the other two very functional compile to JS languages. So it's kind of, it's maybe underappreciated or not known enough, so that's kind of what I'm here to show you that maybe it's a cool thing and you should give it a try. Although I'm also going to be honest about what the downsides or the drawbacks are, and I'm happy to talk about that later on. Like, it's not, I'm not here to just evangelize. Everything's a trade-off, but we'll talk about that later. So Clojure is a modern Lisp for the JVM, for the Java Virtual Machine. It's been around for over 10 years. And Lisp, of course, is a family of programming languages that goes way back to the 50s. So sort of probably the longest still active branch of programming languages. But Clojure breaks with a lot of Lisp traditions. It's very much its own thing. It tries to be a very pragmatic language, a language that's fast, it's easy to use, and especially it's very, very functional. So all its core data structures are immutable, what functional programmers call persistent. It's very much about just plain simple data. ClojureScript then is basically Clojure but compiled to JS. So ClojureScript is written in Clojure and ClojureScript, yes?
I think it's now basically only written in ClojureScript, it's like self-hosted.
Yes, there is a self-hosted version. But the main, so the compiler is written in Clojure, and now the ClojureScript can compile its own compiler, so you can also use it inside ClojureScript. But actually, for most production use, you use the compiler that's in Clojure because of a number of reasons. Part of it is that it uses this Google Clojure compiler, and this is Clojure with an S, so this is kind of confusing, but this has nothing to do with the other Clojure. This is a project from Google that's been around from before Clojure was around. And basically what yeah, I have some slides later on, apparently. I thought they came after this, about the Google Clojure compiler. But basically, the Google Clojure compiler is a optimizing JS to JS compiler, and it's kind of ClojureScript's secret weapon. So why bother? Why would you, leave your comfortable JavaScript behind for something with so many weird parentheses? So JavaScript famously was written by Ben Ike for Netscape in 2 weeks. They needed something to ship with Netscape, and he came up with JavaScript, for better or for worse. The person who created Clojure, and also ClojureScript, Rich Hickey, he has this philosophy of habit-driven development. So he basically spent 2 years reading books, looking at what other languages were doing, thinking about what problems the industry was facing, and then in the end came up with Clojure. JavaScript is becoming more functional, but in the end it's still an OO language, prototype-based inheritance, which is strange sometimes to many. Whereas Clojure, it's based on Java or JavaScript, so there are objects. But if you write idiomatic Clojure or ClojureScript, then most of the time you're just dealing with data and functions. It's a very, very straightforward, very simple paradigm in a way. JavaScript syntax keeps growing, and it kind of had to. There was a lot that needed fixing, that needed improving, and so they've been adding very actively ES6, ES7 stuff to the language. But it also kind of means that it's sort of becoming the new C++ in the sense that it's a language where nobody can keep the complete spec in their head anymore. And everybody just sort of, JavaScript, the good parts, you carve out your space to work in. Which might be fun, but that's sort of the situation where we're in. Whereas Clojure and ClojureScript are very stable, have very stable syntax and semantics, partly because you don't need to change the language to add fundamental new features. So to give an example of that, there's core async, which is basically channels as they are known in Go, communicating sequential processes. This was added as a library. There's core logic, which is sort of a Prolog style logic programming thing. It's also a library. There's core match, which provides pattern matching. It's also just a library. This is because it's a Lisp. This has macros. I don't have time to really explain macros, but it basically allows you to add new features and new syntax to the language. But really what it comes down to is that it will make you a better programmer. So even if you end up not using it in the future, thinking about data, about mutability, about how you structure code in a functional way really helps you. And I've heard this from many people that after Clojure they look at their code in a different way. So the Google Clojure compiler, this is what the ClojureScript compiler targets. So the ClojureScript compiler outputs JavaScript, which you can run straight away in the browser or on Node.js. But if you do a production build, then it runs through this Google Clojure compiler, which is probably the most advanced JS2.js compiler in existence. It's not super well known or not widely adopted outside of Google because it is quite picky about what you feed it. It has sort of its own module syntax. Nowadays it can also consume ES6 and CommonJS modules, but like for the longest time it kind of had its own funky module system. But ClojureScript is fine with that because it can just output what it needs. And so it does that code elimination, also known as tree shaking. It inlines stuff. It renames variables and function names to make it smaller. It does all kinds of fancy stuff. And so this is ClojureScript's biggest blessing, because it means that even though it's a JS2.js language which adds a lot of stuff, and you might think that because of that it's going to be slower, but in the end, it's not necessarily slower or bigger because any stuff that you're not using just gets compiled away. But But at the same time, it's also its biggest pain point because it is not a very well-known thing, and it's just an extra thing that you have to keep in mind. And especially when it comes to interacting with existing libraries, because it does all this stuff, for instance, renaming functions, you need to be very careful how you deal with that, and it can be quite tricky to work with existing libraries. Now there's a growing, a huge collection called ClojureScript, which are popular JavaScript libraries packaged to be easy to use with ClojureScript that sort of have all the definitions that the Google Clojure compiler doesn't mess things up. But it is sort of an extra thing to keep in mind, and I think this is the biggest point where people stumble, especially because usually during development it's all fine, and then you do a minified sort of a production build, and everything's broken, and you get really weird error messages, and you don't know what's happening. So I asked on Twitter, if you had 5 minutes to demonstrate ClojureScript to JavaScript devs, what would you show? What would blow their minds? And I got a couple of replies. Someone said, I've seen people like how Clojure avoids stupid quirks we have in JS. I'll show a few of those. Because you really are sort of in a parallel universe. You know, the semantics are sometimes different. And then this is, I guess, a good list, and I won't have time to go into most of these, but so immutable data structures by default. Beauty of Lisp syntax. This is, of course, when I read this, I was like, yes, that'll convince them. And I absolutely agree with this, but the thing with Lisp syntax is that how many of you remember when you were not able to read HTML? When looking at HTML text was like, this is weird, or it was hard to read. Maybe some of you do if this was somewhat recent, but many of you don't. You know, you look at it and it's sort of second nature. And it becomes the same thing with Lisp, that it actually is in a way easier to parse once you get used to it. And especially, it's very easy to use in an editor if you use the right kind of tools for it. And hopefully I can quickly demonstrate that. CoreASIC, like I said, these spec channels, spec macros, they already have almost anything else. Fair enough. Okay, so to look at a little bit of code just to know what you're talking about. So this is a function called in ClojureScript. It would compile to something like this in JavaScript, so this is part of the standard library. That's what it looks like. And so this thing where the function or the operator always comes first is the same for everything. It's the same for plus, or the same for bigger than, smaller than. And it's the same for instance, an if. Now, I didn't translate this as an if because everything in Clojure is an expression. So this returns a value. So this if 5 bigger than 3, then it returns bigger, otherwise it returns smaller. When you write something like this in ClojureScript, you might think you get a JS array, but you actually get a ClojureScript persistent vector, which is a separate functional data structure, which is one of the things that makes Clojure so powerful in ClojureScript. So there's vectors and maps, which are kind of like JavaScript objects in a sense. This is a keyword. It's kind of, I don't know if anyone's familiar with the JavaScript symbol. It's not super new, but it's kind of a similar thing. It's a unique identifier. Of course, you can do all these things. So now we've switched it around. If you have an array in JavaScript, there's a function for making arrays, or you can use this syntax for having a literal array. Same for JavaScript objects. Like I said, most stuff is pure functions and simple data, but if you do need to use objects and need to call methods on objects, then it looks like this. So again, the function, the operator, the method, the thing that you're doing always comes first. And if you're calling something on an object, then you put this dot there to make that clear. So this is how you resolve. So React.js is the JavaScript global. ClojureScript has namespaces things, so if you just write React.js, it'll try to look that up in your current namespace, it won't find it, so you have to tell it that this is a JavaScript global. Just kind of give you an idea of, I mean, a lot of this stuff will be shielded if you're writing idiomatic code, but so all that interop stuff is there if you need it. This is how you look up a property if it's not a function. This is how you capture this, because this normally is, there is no this because there's no objects. But if you need the current value of this, you can temporarily bind it to a value and then do something with it. This is what an anonymous function looks like. There's no return because, like I said, everything is an expression. It just returns the last thing in the function. So fn, make an anonymous function. Defn, you can define a named function. And so here's some of those things where sort of the semantics are different. So all these Clojure data structures, you can compare them, and it'll do, it's a deep compare in a sense, but because of the way that these immutable data structures are built, it can still be very fast. Strings are not equal to numbers, even though they are in JavaScript, stuff like that, just to give you a few examples. And then a final example, sort of what Clojure excels at is working with data. And so here I have some nested data. So def, it's kind of like var, but or const, I guess, it defines a constant in a sense. So I've assigned this map with users, which is a vector which contains 2 users, to data, and then I want to get back a similar data structure, but with the count for Arne increased by 1. And so I say update in this nested data structure, traverse this path, so go into users, take the first, like not 0, but 1, take the count, and then run the increment function on that number 0. And so this doesn't update this in place, because that it never does in ClojureScript. Once you have a value, once you have a data structure, you never change anything inside that, but you get a new value back with that count increased by 1. Okay, so that's a lot of preamble. Let's talk about React. So all this interop is there, so you can just pull in React and start using it. But of course, that's kind of horrible. I mean, these are some helpers, which means that you can then write something like this. So this, you have your elements and you have components, you have a render function, like all the stuff is there. This is from a toy example that I made an episode about. But it's not super nice. It's much nicer if you use one of these wrapper libraries. So there's a handful of them. Ohm is probably the most well-known outside of the ClojureScript community, because several ideas of Ohm kind of influenced JavaScript stuff. For instance, Ohm was the first library to demonstrate that you can actually make React faster by using immutable data structures. But my preference kind of goes out to Reagent. It's a much easier syntax. Run and quiescent are also around. And so these combine React's UI programming, which is really about having a functional paradigm for your UI. Being able to say, okay, here's data, and I have a pure functional mapping to the state of my user interface. And if my input data, if my state changes, then my user interface changes. So a lot of talk about React is about performance. Why is it about performance? Because Facebook came up with a way to do this fast enough. But really what it's about is not having all that mutable state lying around, not having that big mutable DOM, but instead having a very nice functional paradigm. And so this marries beautifully with ClojureScript's functional data structure and functional approach to programming. So like I said, my preference goes to Reagent. In Reagent, you use something called hiccup syntax. So in JavaScript, you would use JSX. We just use basically Clojure vectors, and so these would turn into elements. A component then is just a function which returns this hiccup syntax, so it returns a data structure that describes your DOM. See here that, so I have a to-dos component, it takes a bunch of to-dos, I'm sort of mapping over them, this is a list comprehension, returning an element with as component to-do item, which is this one, it gets a to-do, renders the to-do element. Once you get used to the syntax, it's reasonably straightforward. And then there's reframe, which builds on top of Reagent and is similar to Redux. And it was interesting kind of to talk before this, because a lot of the stuff that he talks about, these performance hacks of making sure you use should component update in a good way. Again, this is having good value semantics and equality semantics means that that's one of the core things that these React wrappers for ClojureScript do. They make sure that you don't render more than you need to, and they're quite good at that. And so in Reframe, you have a central data store, which they call their database, and then you have subscriptions. Your data flows through subscriptions to your components, and then your components trigger events which update your database. So this is, you give it a starting value. For instance, this is, so what we're talking about is this here. This is a level editor, so to say, for the classic retro breakout game. So this is my initial state. There's a selected color, and then I have a nested map for the blocks. It's sort of X, Y, color. And then you register these subscriptions. You say, okay, well, from my database, I can get the current selected color or the current color, and then you can use those subscriptions in your components, and only when that part of your database changes will that specific component re-render. So most of the time in React, you re-render your whole tree, but Reagent actually uses some lesser used or discouraged APIs, but it knows how to do it in a good way, that it can very selectively say, only this component needs to re-render right now. And then you have events. For instance, when you want to create a block, then you can trigger the create block event, which then takes your current value of the database and returns a new value of the database, which if you don't have a valid color selected is just the old database, or if it is, then it's the updated value of the database with a new color associated in at a certain position. And it's not a full tutorial on ClojureScript, but I hope it kind of makes sense. And I guess that's just 20 minutes, so I'm going to take like 1 or 2 more minutes just to show you a couple things, and then you maybe have 1 or 2 questions. So I'm using Emacs. Emacs is quite popular in the Clojure world because it's always been very good at dealing with Lisps. And so here I did a command that starts my REPL and then open my browser, and so now I have this REPL that is connected to my browser. So I can try stuff out there, and it evaluates it, compiles it, sends it to the browser, evaluates it, gives me the result back. I can also do that inside a buffer, sort of evaluating code. Yeah, I guess this is a little bit small. So say, for instance, blocks. Blocks uses a subscription to get the current list of blocks, loops over them, and then passes. It gets an X coordinate and a list of blocks, which it passes to the block row component. Now the block row component, so the block row component here gets basically a map. It's called a row data. But so it can destructure that, saying that, okay, inside this map there should be blocks and an X. This is kind of like some of the stuff you get with the newer JavaScript. There's various ways that you can destructure data structures as you get them. Loops over that. Here you see that as you click on a block, it dispatches the block clicked event with an X and a Y, which is then handled over here. So yeah, I guess I gave you a taste. I'm very curious, sort of, like I said, this is the first time I'm doing this talk. I'm very curious, sort of, to hear how does this perceived by people in the JavaScript React community. So definitely come and talk to me afterwards. But I still have time for a question, I think. Any questions? Yes?
I think the argument that I would be more interested in hearing is the difference between ClojureScript and Elm. Like, I've been using React for a while now, and now I'm like more interested in these like functional languages.
Mm.
So like and when you look at the syntax, it looks a lot like Elm. So this is the argument that I would be willing to hear. Like, which one is better to learn for what reasons? Like, I think that we all find that React gets small and short a lot of times. So these functional languages are really interesting. But like, which one to learn next and why?
That's a very good question. I haven't done a ton of Elm, but I can give you sort of a broad answer. So one big difference is that Elm is really perceived or conceived as a UI programming language first, but I think they're moving it more into a general purpose programming tool, whereas ClojureScript is a general purpose programming language which happens to work really well with React. So you can do all kinds of other stuff with it as well. Elm is an ML style language, so it's statically typed, which is, I find, mostly a matter of taste. It has pros and cons, but if you like static typing, or if you sort of appreciate the benefits of static typing, then maybe Elm is for you. But I can't really give a much better answer than that. I think there's a lot to be learned from trying them both, or trying one of them. There's a lot of good ideas in them.
Does this work well together with stuff like prop types from React, or?
So this is validation that you can do on your properties, right? Yes. So the thing is, Clojure and ClojureScript last year introduced something called ClojureSpec, which is a similar concept in that it gives you a language for specifying the structure and range of values, but it's much more broad, so you can basically use it on any value and on any function. And so you find that ClojureScript people that want that kind of checks would rather use spec.
Is it easy, say someone wants to move their existing code base for us to use ClojureScript? Is it something that happens, that's possible? Or is it possible to like combine JavaScript and ClojureScript in the same project? It
is. And it's also something that is really improving. So like I said before, the Interop story has always been a bit of a pain point. The language level interop has always been there. It's very easy to call stuff in JavaScript and vice versa. But because of like consuming, for instance, packages from NPM is still a bit too hard, but they're working really hard on making that easier. You can definitely combine things like, for instance, Reagent allows you to use React components written in JavaScript and allows you to expose your Reagent components to React. So that's all possible. Setting it up so your build is working properly and your optimizations all work properly, that's kind of a different story. So there's kind of different ways of doing it, right? Like if you're mixing ClojureScript and JavaScript code, the question is, do you want that JavaScript code also to be optimized by the Google Clojure compiler or not? If not, then it's somewhat easier. Then you just have to make sure that Google Clojure compiler doesn't mess up your calls to that other code. But for this, you just add it to the build unminified, like, okay, just smack it on. That's pretty easy. If you want everything to kind of go through that, which would be super nice, then it gets harder. You need to give it more hints, and especially if you do a lot of sort of dynamic programming, it does static analysis, right? It tries to analyze your code to see, okay, where is this function being used, stuff like that. And so if you do a lot of dynamic meta programming, that kind of stuff, it's definitely going to mess up. So yeah, your mileage will vary, but it's improving. That's what I can say. Yeah.
Does the Clojure compiler allow you to do bundle splitting or something? Or what's the footprint of a normal ClojureScript app?
So the footprint, like I said, it does that code elimination and tree shaking. So if you just, if you have a hello world, then it's, not bigger than the same code in JavaScript, because you're not using any of that ClojureScript standard library stuff, and it all just gets optimized away. It does, you can do module splitting with it. I haven't seen a lot of people doing it, and I think it's still a bit tricky to do it properly, but it does support that kind of stuff, that you can say like, okay, different parts of my application use different parts of my code base, and so I have different builds that are sort of optimized for each. It does do that, but it's not trivial.
Okay, thank you.
Yeah.
Okay, one more question.
Okay, last question.
Okay. Or not?
Yes.
So, I mean, I understand the interest and the beauty of all of this, but to be honest, if you have now a team of maybe, I don't know, 10 developers or so, and then you start doing Clojure, and do you find actually more developers who are able to maintain and evolve the code, and what's your experience on that? Are people, like, maybe for really large companies using this in production and for their code base?
There are definitely large companies using this in production.
The large ones I can imagine by say like 50 to 100 developers or so, then I think it's probably difficult, right?
It is, I mean, but it kind of goes both ways, right? Like, so it's a smaller scene, there's less developers, but there's also less jobs on offer, and you see that this is like Haskell, you know, like Stack Overflow on Haskell is always much more active in the weekend than during the week, because it's the kind of thing that people are interested in and that they like spending their time on. And so there is a certain amount of people that are eager to find those Clojure jobs. So it kind of, you know, yes, there's less developers, but there's also fewer jobs, and it kind of goes both ways. But if you're really going to build a big team on this, you're probably going to have to count on some in-house training, I suppose. Okay, I'm still here. I would love to chat to you all. I also have stickers from Lemon Island. So.
Great. Thank you very much.